Myself, Anil Kumar K, PTO Research Scholar, working as a research scholar in the Department of Mechanical Engineering, MSCC, Bangalore. I am very glad to present my paper in International Conference on Computational Intelligence in Machine Learning on the title called Numerical Modeling, Parametric Optimization and Prediction of Cutting Tool Life for Aluminum 6351. So overall overview of this paper is as per this: abstract, literature review and summary, methodology I have followed, modeling of cutting tool life, optimization of cutting tool life, results and discussion, experimental, confirmation, conclusion, reference. So in order to predict the cutting tool life, here I am developed modeling, optimization and predictive model by using two artificial intelligence approaches such as ANN and genetic algorithm. So here the results proposed is having a good agreement between the predicted values and evaluated values. By this analysis, we can prove that the proposed approach is capable of determining the optimum machining parameters. So since last few decades, so many authors have proposed different methods to predict the cutting tool life and for optimization. Here some of the authors those have proposed different methods such as Al-Ahmari proposed response surface methodology and neural network. Gupta has proposed RSM and ANN and SVR. So Jaffrin, ANN, genetic algorithm and particle swarm optimization methods, and Lahari, response surface methodology, Box, Benhen and design. Different methodologies are proposed. So based on that literature survey, it is observed that some of the cutting parameters such as speed, cutting, depth of cut will be a very important role plays in turning on cutting tool management. So in this research, a method is proposed called ANN feed forward backpropagation algorithm, Levenberg Marquardt algorithm, by considering above parameters. And also design of experiment is selected based on the Taguchi L27 array. So the methodology I have followed in this research work is: first I have done the turning operation using CNC machine on material called aluminum 6351 T6 by using a tungsten carbide tool. So first I have designed the experiment using Taguchi design of experiment, and I have analyzed the tool life based on the flank wear rate. So later I have identified the optimum parameters to tool life, and later I have predicted the tool life by using the ANN feed forward Levenberg Marquardt algorithm. So after that, the tool life improvement is done by genetic algorithm optimization. So this is the architecture of the proposed ANN model. So I have selected three inputs: speed, feed and depth of cut, and hidden layer. I have selected single hidden layer and one single output response, that is a tool life. So here I have varied by considering only one single layer, and in the single layer, in the hidden layer, I have varied number of neurons. So here three inputs. So based on the trial and error method, these three models are best fitted. Out of these three models, further I have identified which is the best fitted model. So the first model I have selected is 321, and second model 325.1 and 331. So generally we can express as 3 and 1. So the neural network is trained by using feed forward backpropagation algorithm using the MATLAB. Okay. So here 15% of the data what we have collected is have used for testing, and remaining 70% for validation and training purpose. So optimization of cutting tool life. So two methods I have used. One is response surface methodology and one more method I have used, let me discuss later. So as for this response surface methodology, here the collection of mathematical and statistical technique is used for approximation or optimization of stochastic function. So by this response surface method, I got the mathematical model, that is to maximize this mathematical model I got for this constraints, that is speed, feed and depth of cut. So later I have optimized using genetic algorithm. So two optimization, one is for response surface methodology and one more by genetic algorithm. So this genetic algorithm optimization mainly used to solve complex problem through natural evaluation. So here I have used the toolbox called MATLAB, used in genetic algorithm toolbox in MATLAB I have used for the optimization. So these are the results, experimental results for these different parameters based on the L27 orthogonal array. So based on the tool wear rate, I have predicted the tool life for the all these 27 experiments. So as for the experiment, after experimentation, I have observed that flank wear is mainly dependent on feed and speed. As the speed increases, the flank wear increases, and also with the feed rate increases, the flank wear increases as shown in the figure 4. And also for tool life, as the speed increases, the tool life decreases, and as the feed rate increases, the tool life decreases. These two graphs clearly shows that speed and feed mainly depends on the flank wear and tool life. So these are the ANN training phase results for the different models, that is 321, 325 and 331. So I have calculated the prediction result for all the three models. So later I came to know that based on the regression values for 321 model, the regression value is 0.96877. If it is exactly nearer to 1 means it will be a better fitting model. So let me see for the 325-1 neural model. So the 325-1 neural model, it is 0.9915. Next 331, it is 0.97. So out of these three models, so 0.9915 model, that is for 325-1 model, neural network model, that is R value is 0.9, it is very nearer to 1. So 325-1 neural network model is the best fitting model. Also I have calculated the mean square error for the all three models, though for 325-1 model it is very less, that is 16.91%. So I have selected the 325-1 model to predict the tool life. So this is a comparison between the experimental and predicted tool life. So by this comparison we can conclude that there is a close relationship between the experimental tool life and predicted tool life. So later optimization of cutting parameters using response surface methodology. I have used Minitab for the response surface methodology optimization. So here the current optimal parameters are speed 78 meter per minute, feed rate 0.1 mm per revolution and depth of cut 0.2 mm for achieving the maximum cutting tool life. Okay, so that is the parameters required. So this is optimal parameters what we have achieved by RSM using Minitab software. So maximum tool life we can achieve up to 99 in RSM. So later I have used the GA toolbox in the MATLAB to optimize the tool life model by using the population size of 200 and training rate, crossover rate, that is 0.8, and mutation function, uniform mutation function, and scale function and selection function are rank and uniform respectively. So this is the optimized results I got through the GA. So optimized result tool life is 98.75, I got it. So let's see from RSM and GA. So we'll get GA validation error will be very less when compared to the RSM, because experimental tool life 98 we got through the RSM response surface methodology it is 99.08, but GA through the GA it is got 98 is 8.67. So that validation error is less in case of GA. So we can conclude that genetic algorithm optimization will give the best optimal result when compared to the response surface methodology. So finally, here we can conclude that ANOVA revealed that developed mathematical model using RSM allows a prediction cutting to within the 7% error. So here the cutting speed is the main influencing factor on the cutting tool life with 89.53% contribution, followed by feed rate with 99.4%. So here ANN provided a close relation between the predicted values and experimental value. So the mean regression error between the predicted and experimental value using ANN is 4.19%. So the developed predictive models are compared using mean regression errors and validated using hypothesis testing. So it has been found that ANN model is better than response surface methodology for predicting the cutting tool life. Next, confirmation experiment carried out using the optimum machining parameters shows that developed predictive and optimization route response surface model and GA model can be used for turning aluminum 6351T6 alloy with 1.102% and 0.68% error respectively. So from this we can conclude that GA model is better than response surface methodology for optimizing the cutting parameters for maximum cutting tool life. So by this conclusion, and I have referred, these are the papers I have referred for reference. By this conclusion, I will end my presentation. Thank you.